This is video 1 from Unit 5, Lesson 2. We're going to solve systems of linear equations, this time with substitution. Okay, so remember, systems are two or more equations together. Our solutions are ordered pairs. On a graph, it's where they intersect. But we can actually solve them without graphing. All right, so these are the steps. Find the equation that has either x or y by itself. Okay, so let's look at an example. All right, so the equation that has x or y by itself would be the bottom one. It has a y equals. Okay, we're going to substitute that expression in the other equation to find the solution of one variable. Okay, so y equals x plus 2. So I'm going to put a box around that. So y equals this box. So that means I can plug this box in for y. So instead of y, I'm going to have x plus 2. Since there's that 3 in front, when I substitute it, I have to put parentheses around it, so I remember to distribute. Okay, so now I see in this equation I only have x's. So I can solve when you only have one variable. So 3x plus 6. And then we want to combine like terms. That's 7x. They're on the same side. So we do the same, keep the signs the same. Okay, and subtract 6. Negative 21, divide by 7, and I get x equals negative 3. Okay, so I have x. I need to find y, so that's the last step. Substitute that solution into one of the original equations to find the other variable. All right, so I have x equals negative 3. I need to find y now. So I'm going to plug this into one of these two original equations. Usually the one that you substitute is the easier one, so this right here. So I plug negative 3 in for x. And then all I have to do is negative 3 plus 2, which is negative 1. So my solution, we write as ordered pairs x comma y, is negative 3, negative 1. Remember, you can always plug this in to check that it's correct. So 4 times negative 3 plus 3 times negative 1. I want to know, does that equal negative 15? That's negative 12 and negative 3, so okay. So it works for the first one. And the second. So I know my answer is correct. Okay, let's do that a couple more times. So it's the second one again that has the y equals or x equals by itself. And it's y, so I'm going to plug that in for y. You can have x by itself as well. Okay, so I have to be careful here. I'm distributing negative 6. So negative 6 times negative 6 is 36x. And then negative 6 times 34 is negative 204. So 3x plus 36x is 39x. I need to add 204 to both sides. That's 234. Divide by 39. And we get 6. Okay? We need to now plug that in to find y. You can choose top or bottom, but the second one is usually the easier one. The one that you substitute in. It's not always the second. Okay, so negative 6 times 6 plus 34 was negative 2. So my solution is 6, negative 2. Plug it in to check to make sure it's correct. Okay, so let's look at this one. So this one here is, they're both h equals and h equals. You have, both equations have a variable by itself. So you can choose, do you want to use the top or the bottom? So let's pick the top this time. And it's h equals, so that means the box goes in for h. There's nothing in front of h, so I don't have to use parentheses. Okay, so now I'm solving this, and I want to combine the 6g and the negative 2g, but they're on opposite sides, so I have to do the opposite operation. And when I say sides, I mean sides of the equal sign. And then we're solving, so add 4, divide by 8, and g equals 4. Okay, and we're going to substitute that back in. So h equals 6 times 4 minus 4. And I got h equals 20. So when you do variables that aren't x and y, your ordered pairs go in alphabetical order. So g then h, so 4 comma 20. Okay. All right, let's look at a couple others. All right, this is the second equation again. So it's not always a second. This x equals could have been on top. Just these examples don't have that. But that's the one I want to put the box around, the one that's x equals or y equals. Since it's x equals, it has to go in for x. And there's a number out front, so I have to use parentheses when I substitute it. So negative 6y plus 30 Okay, combine your like terms. So negative 6y plus 6y is 0. So those actually cancel. So I'm left with 30 equals 70. Okay, so it's a special case. So if your variables cancel, then we have a special case. And we have either a no solution or infinitely many solutions. Well, 30 does not equal 70. That is false. So this would be no solution. So on a graph, these lines would be parallel. Okay, let's look at this one. It's y equals, so this goes right in for y. So I rewrite the top equation. I don't have anything in front of y, so I don't have to use parentheses. Okay, combine your like terms. Again, they cancel. and you're left with 20 equals 20. Well, that is true. So this one would be infinitely many solutions. Okay, so these are only special cases that happen every once in a while, and if your variables cancel, then it's going to be either no solution or infinitely many solutions. Most of the time you get just a normal answer, a normal ordered pair, like these two here, but there are some special cases where you don't. Okay, we're ready to do Unit 5, Assignment 3.